Okay, so we're back again with physics question number 3. A particle is undergoing uniform circular motion in the xy plane such that its distance to the origin does not change. At one instance, the particle is moving with velocity v equals to 10 meters per second in the x direction, and with acceleration a equals to 2 meters per second in the y direction. The question asks us what is the radius of the circle? Okay. So this radius of this question is fairly straightforward as well. We're given, let's solve this. Yes, 3a. Okay. So 3a, we need to use centripetal force for this equation. Yeah, let's do that. So we know F equals to ma, right? And force of centripetal mv squared over r. Okay, we can cancel this. So a equals v squared over r. That is an equation, I believe, that is very, very well known, and you should know about that by now. Okay, so I'm not going to tell you how to go from there. So we can go from r equals to v squared over a, and we're done. R equals to 10 squared, which is 100. A r equals 100 over 2, which then equals to 50 meters. So this is your radius. Okay? Next. How long does it take for the particle to travel once around the circle? What is the period of motion? Okay, so one time of travel was 360 degrees. That is apparently equal to your period, which is true because period. Okay, that's also very simple. We know the equation for it as a equals to omega squared r, right? A equals to 4 pi squared r f squared. A equals 4 pi squared r t squared being your period. Then t squared equals 4 pi squared r a equals equals 4 pi squared times 50 over 2. 1, 2 equals 2 pi squared 50, which is squared equals t squared, cancel 10. That's your number 2 as well. So okay, let me explain what I just did there. Your angular velocity, omega, square that multiplied by your radius, that equals to your acceleration. That should be given in your formula sheet. If not, let me know and I will show you how to derive that equation. A equals to 4 pi rf squared, okay? How we got that was very simple. Omega, okay, omega itself equals to 2 pi, okay? Omega 2 pi f, okay? Omega, let me write it here. Omega equals 2 pi f. That's how we got this 4 pi right here. 4 pi squared and f squared, okay? Because if I square this term, that's going to be 4. Square this term, that's going to be a pi squared. Square that term, that's going to be a f squared. F being frequency. And as we know from this, okay, as we know from this, omega equals 2 pi f, and f equals to 1 over t if I went 2 pi multiple 1 over t, that equals 2 pi over t. Okay, if I square that, that's going to be 4 pi squared over t squared. Same, that's how I got this part in my equation. Okay, then we go around just doing basic arithmetic, and then we get our period as t equals to 10 pi. From there, we are now good with this equation. Okay. The next question asks us, in what direction would the particle be moving after a quarter of a period? So a quarter. So this is a circle here. Okay. Not a very good circle, but this is 0. Okay. This is 90 degree, or your 1 quarter. This is your 1/2, 180, right? That's 270 and a 3/4, and then this is your 360, 360, or this is your 1 full, right? Very simple. Okay. So for this one, it asks us the particle will move in a 90-degree direction and make 180 degrees from the x direction. That is C. Okay, and that is it. Okay, let's put it here. C. Particle will move in 90-degree direction. And this particle will move in 90-degree direction and make 180 degrees from positive x direction. And how we got that was fairly straightforward. That's because if we had a circle here, a period, so that means 1 full rotation will be 10 pi, or also known as your 0 mark. Okay, a quarter, that means it's 2.5 pi, half 5 pi, and here, which is 7.5 pi. Okay, and then go back to 10 pi. So that's one successful 1 period. We go this way. Okay. Now, if 10 pi was here, that means after a quarter pi, which is our 90 degrees, this will go to 180 degrees, which is 180 degrees from positive x